A very good morning to all of you who are watching this video. Today in this video, I will show you how to develop a program in Python language for calculating the point biserial correlation in data analysis. As we know, Python language is high level language and it is used for the general purpose. Developing a program in Python language for solving our statistical problem is an interesting task. But before proceeding to the Python language program, I have some questions for all of you. Do you have interest in statistics and programming? Do you want to learn to do something new? Do you want to learn a new skill and become proficient in that skill? Do you have to interest in statistics and coding? Do you want to solve your statistical problem by making your own program? Do you want to do something new by looking at statistics from a new perspective? If your answer is yes, then this video is for you. I am Dr. Jaising, and in this video I will show you how to develop a program for calculating the point biserial correlation in Now, I will show you how to calculate the point biserial correlation with the help of Excel software. And after this, we will show you to make the program with the help of Python language. In Excel, suppose a problem is given to find the point biserial correlation in which 15 students are administered on a test and the score obtained by these students are 25, 23, 18, 24, and up to 21 and 22. And in that question paper there is an item that is, suppose it is 13th, in which there are two responses. One is for correct, true, and zero is for wrong. And some students have attempted item number 13 correctly, and the number of students who attempted this question correctly is 9, and 6 students have not attempted it correctly. So we are eager to find the correlation between the two groups, and one group who have attempted item number 13 correctly, and the another group, second group, who have not attempted this item number 13 correctly. So we can separate this into two parts, and you can see here that true dichotomy is here because 1 and 0 are discrete points. So point biserial correlation is appropriate method for finding the correlation. The formula for finding the correlation coefficient is R biserial is equal to point biserial is equal to m1 minus m2 divided by sigma multiplied by square root of p into q. In this problem, R point biserial, where the R point biserial shows the point biserial correlation coefficient, m1 is the mean of the first group, m2 is the mean of second group, sigma is the standard deviation of the total group, and p is the proportion of first group, that is the number of the students who attempted it correctly divided by total number of the students, and q is the proportion of the second group who have not attempted it correctly. Here you can see mean of the first group is 22.33. This is the mean of the scores of 9 students who have attempted it correctly, and M2 is the mean of the second group, that is 20.33, and M total, mean of the total group, is 21.33. Standard deviation of this, which is calculated, is 1.82, and the proportion of first group P is 9 divided by 15. 9 is the number of the students who have attempted it correctly, and 6 students have not attempted it correctly. So Q is equal to 6 divided by total number of the student, that is 15. Hence P is equal to 0.60 and Q is equal to 0.40. Now, with the help of Excel software, we will calculate the correlation coefficient, point biserial correlation coefficient. So in a cell, first we type equal for making it formula, equal bracket M1 minus M2, but it will be better to fill the value. The value of M1 is 22.33, 22.33 minus M2 20.33 multiplied square root SQRT square root of first number, first proportion P, that is 0.60, multiplied by second proportion 0.40, and close the bracket, and then divide by standard deviation, that is 1.82, 1.82, and click. We find the value of the point biserial correlation coefficient is 0.5383, which is approximate value. Approximately it will be 0.54. Here Visual Studio is open, and in this studio we will prepare a program for calculating point biserial. In the first line, first we will write the heading of the program. So we write print bracket double inverted comma. To make this as a string, we write the heading point biserial correlation, point biserial correlation program. And in the next line, we will write, as we know that in Excel and in formula for the point biserial correlation, we need to insert the value of M1 and M2, sigma and PQ. So for input the value of M1, we will write, first we will write the print bracket double inverted comma to make it as a string, and fill the value of mean of first group, that is capital M1, and it will be visible in programming in outcome, and then we need to insert the value of M1. For this, we will write M1. First, we define the variable. M1 is variable for mean of the first group is equal to, the nature of M1 is float. So we write float. It may be integer, but float, by writing float, we will be free to write the numbers in decimal, and then comma, sorry, bracket, and we write input again small bracket. So with this we will be able to give the value of input. And after this, in the next line, similarly we will write print fill the value of mean of the second group, mean of second group, and for inserting the value of mean of the second group, we will write code in Python. And for this we define m2 variable, m2 that is mean of the second group, and the nature of this is float similar to m1, and bracket input again bracket. So m2 will be inserted, and in next line similarly we write print double inverted comma under small bracket, or make it a string not number or float. So print we require the value of sigma, insert input, fill the value of fill the value of standard deviation, that is st of total group, and for input the value we write program st small st. This is symbol for a new variable is for standard deviation. SD float, its nature is like a float, and bracket input again bracket close. And similarly for p and q we write print double inverted comma under small bracket fill the value of first proportion first proportion, that is p, that is p, and we write program for input code small p, we define it is like a p, and p is float equal to float input and bracket float fl float, and then again we write print bracket double inverted comma fill the value of second proportion second proportion, that is q, and we define small q as float bracket input again bracket, and then all the variables have been defined m1 m2 standard deviation p and q. Now we write the code for mathematics, because we need the standard deviation, and for this we write import math. So mathematics formula will be applicable like standard deviation. Some formula are applicable, but some are not. But by importing math, all the formula will work. And after this, we write enter, we write print bracket double inverted comma by the value of point biserial correlation. The value of point biserial correlation will be will be and now we will define the formula. First we see in the Excel file the formula is R point biserial is equal to m1 minus m2 divided by sigma multiplied by square root of p into q. So where R point biserial is point biserial correlation coefficient, m1 is the mean of first group, m2 mean of the second group, sigma is the standard deviation of the total group, p is the proportion for the first group, and q is the proportion for the second group. And for this formula, m1 minus m2 upon sigma under root pq, we write quote, we write, first we define the variable r p biserial, point biserial is equal to R P biserial is just the alphabet which shows the correlation coefficient for point biserial, and here we define this term as a variable, and this is equal to bracket m1 minus m2 multiplied by square root. For square root we write math dot sqrt. Already we have written the tag import math in the 12th line, and here we write only math dot sqrt square root and bracket p multiplied by q, because we need the square root of p into q, and then define divide it by standard deviation, and the variable name is small sd for standard deviation, which is given in 7th line. So we write sd, directly we write sd, and then hope that it will work, and we run this program and see the effect. So click here to run the program. Now in the output of the program we see that fill the value of mean of the first group m1. So we fill here the value of m1, and in Excel, in the same problem, we see that the value of m1 is 22.33 and m2 is 20.33. So we fill this value in the output 22.33, enter 20.33 for the value of m2, and then we enter, fill the value of the standard deviation, and the value of standard deviation is 1.82. So we enter 1 point, we fill the value 1.82 for standard deviation, and now here it appears, fill the value of the first proportion p, and the proportion, first proportion p is 0.60, and q second proportion q is 0.40. So we enter this value. For the p, we enter 0.60 and enter, fill the value of q, that is 0.40, and all the values which are required for calculating this have been filled, and then we click enter, and the value of the point biserial correlation is visible here, but the result is not being shown because in the last line we have not inserted the tag for print. So we delete the output, and again we write print result, and print result is not written, so it is not showing here. So print, and the variable is rbis, point bis, pbis, pbis, which is defined in 12th 14th line. RBIS is equal to m1 minus m2 and into maths square root pq divided by standard deviation. And then, since this tag was not there, so result was not being shown, and now it will be shown print rbis. Now again we run this program and fill the value. First group mean, that is 22.33, enter. Second value 20.33, fill the value of standard deviation 1.82. Please again we check it, 1.82. Okay, this is 1.82, and enter, fill the value of the first proportion, that is 0.60, and enter the value of q, that is 0.40, and then in the last line, uh, here you see the value of the point biserial correlation coefficient will be, value is showing here 0.53834939, like this, which is equal to 0.54, and same as we obtained this value 0.53 in excel. Using the excel, we have already find the value of r point biserial 0.538349, and same value is being obtained by this Python program. So this program is working, and this I hope that you will like this coding program.